Let's solve the questions. Okay, limit 1 upon n is 0. Like in previous class I explained the convergence of sequence. Before going to the next topic, let's solve some questions. Okay, so our topic is convergent, okay, of sequences. So we prove that this limit is equal to 0, although we know the value is absolutely true, but is for now proof. Okay, now the convergence of definition says that, like, if the limit of x is equal to xn, so we can say that for n is greater than equal to kth term, so the after that the difference between last limit and the initial is less than the epsilon, where epsilon is greater than 0 and small part. Okay, so we use the definition of it. Okay, now so since epsilon we can say that is small, very small. Okay, epsilon is very small. Like the k, after the case term we can say that after the case term the all the value the xn minus of x is always less than equal to the epsilon part. Okay, now the main solution. Since the epsilon is small, so we can say that the k is a large number greater than equal to epsilon, the small number, and 1 upon k, if I reciprocal it, is we can say that again is less than epsilon, because the large, you know, the large amount, okay, the over value decrease. This we can say the equation 1, and we know that, okay, like n is greater than equal to k, we can say that the 1 upon n is less than k, and we can also say that the 1 upon n is less than equal to 1 upon k, and we know that this 1 upon k is again from the equation 2, we can say that from both you can say that 1 upon n, okay, is less than 1 upon k and is less than epsilon. So we can say that 1 upon n is less than epsilon. So according to the proof, by the using this proof, like say this is the a, so by the a we can say that, by a we can say that 1 upon n minus of the final limit 0 is less than epsilon. So 1 upon n is less than epsilon. This was we proved. Okay, the second question is, okay, the second question is quite interesting. We say that 1 upon limit of n square plus of 1 is equal to 0. Although the answer is very obvious by intuitive way, but we can solve it. We use the same logic. By the way, we can use the method 1. I like it. So like the n, we know this is greater than equal to k, and we also know this k is greater than equal to epsilon, because k is the large number. After that term, the all value, like after this definition, we can say that all the xn minus of x is less than epsilon when k is greater than, after definition of n is greater than equal to k. Okay, so n is greater than equal to k, the square of n is always greater than equal to k square. If we add n square plus of 1 in the both sides, we can say that also is greater than equal to both sides. The reciprocal is same, like 1 upon n square plus of 1 is less than 1 upon k square plus of 1. Okay, and we can also say that the 1 upon, like, k square plus of 1 is greater than k square, so we can say that 1 upon k square plus of 1 is less than 1 upon k square. Similarly, we can say this is less than 1 upon k square and is less than 1 upon k. Okay, 1 upon k, and 1 upon k is again less than epsilon. So by from this we can say that 1 upon n square plus of 1 is less than epsilon. So we prove like 1 upon n square plus of 1 minus of 0 is less than epsilon. This was the hence proved, like 1 upon n square plus of 1 less than epsilon. And second method we can use here, like method 2. It is quite interesting, like n square is greater than equal to k, we can k square, we can say that 1 upon n square, basically sorry, the n is greater than equal to k, so we can say that the n square plus of 1 is less than equal to 1 upon n square, because we know, and the 1 upon n square is less than equal, the less than is 1 upon n square and is less than 1 upon n. Okay, and we can say that since by the question number 1 we previously understand the above, understand, like it was quite interesting, so this can be less than epsilon, so we can say that n square plus of 1 is less than epsilon. So we just prove two things, n square plus of 1 minus of 0 by understood that. So we prove these two things and try for if the limit 3n plus of 2 divided by n plus of 1 is 3. So solve for it. We'll meet in next class by the more questions, and then we go to some theorems relating to the convergence of sequence. I hope you understand. Bye bye.